Hello students. Today we are going to discuss again inverse trigonometric function part 2. We have already covered definitions of four functions, that is sin inverse x, cos inverse x, tan inverse x and cot inverse x in the previous session. Now we are going to see secant inverse x. Again, how to draw the graph of secant inverse x? First we need to know what is the graph of secant x, and then from that we will replace x and y coordinates and write secant inverse x graph. So first, what is the graph of secant x? Graph of secant x. We know secant is reciprocal of cos x. So what is cos x? Cos 0 is 1. So secant 0 will be 1. Cos 90 is 0. So secant 90 will be 1 by 0, that is infinity. So graph will be like this. As cos is an even function, secant will also be like that. So this is symmetrical about y-axis. This is 0, 90 and this is minus 90. Next, what do we have from here? Again, secant 90 to 180 will be negative value, so it will be like this. Same way here. This will be 180. So this is how we should draw the graph of secant. Sorry, this is 180, this is 270. At 90, 270, secant will become infinite, undefined. At other places, 0, pi, it will be 1 or minus 1. So graph of secant x is like this. Now from this, what do we understand? For finding inverse function, we need to know, we need to restrict the function into bisection. How to do that? We will take this function so it becomes 1 to 1 and 0 is near that interval and preferably on positive side. So when we consider 0 up to pi, we have 1 to infinity and minus infinity to minus 1. That is the range of secant x. So what we will do is take this region 0 to pi. 0 to pi. This region covers all the values of secant from 1 to infinity as well as minus infinity to minus 1. Similarly, we can take any interval pi. We can take any branch. And in this branch, if we consider this branch, it has 0 in it and it is positive side. So we will take this branch as principal value branch for secant inverse x. So this is principal value branch. Now, how to draw the graph of secant inverse x? What is the domain of secant x? Domain of secant x is all real numbers except odd multiple of pi by 2. So, domain of secant x is all real numbers minus odd multiple of pi by 2. So this will be the range of secant inverse x, and what will be the range of secant x? Range is from minus infinity to minus 1, minus infinity to minus 1, union 1 to infinity. And this value will become domain of secant x. Range of secant x is domain of secant inverse x. So what is the domain? Minus infinity to minus 1, from minus infinity to minus 1 and from 1 to infinity. 1 to infinity. This is the domain of secant inverse x, and range is all real numbers except this value. So we have already restricted this value from 0 to pi. That means odd multiple of pi by 2 is only one value. So we will mark 0. At pi by 2, inverse does not exist, and pi. This will be the range of secant inverse x. So how to draw the graph now, students? Just plot in reverse manner. Secant 0 is 1. That means secant inverse of 1 will be 0. Secant inverse of 1 is 0. Then secant 90 is infinity. That means secant inverse of infinity is 90 degrees. So graph will be increasing like this. What about the next region? From 90 to 180 minus infinity. So secant minus infinity is again 90 degrees. Secant minus infinity is 90 degrees. And secant 180 is minus 1. So this is minus 1. So graph will increase like this. This is the graph of secant inverse x. And what is the domain and range, students? Domain is all real numbers except minus 1 to 1. Range is 0 to pi except pi by 2. This value pi by 2 is not in this interval. This is the graph of secant inverse x. As you have seen, secant inverse x can be written as either like how we written in previous, or we can write arc secant. Both are same. And remember, always angle is the output of inverse function. Graph is given like this. From 1 to infinity this value, and minus infinity to minus 1 graph. Okay, next question. We should simplify this. Secant inverse of 1 by 2x square minus 1. X is given between 0 to 1 by root 2. That means when we substitute 1 by root 2, it will be 1 by 2, 1 by 0 will be there, and it is less than 1 by root 2. So this value will be positive number. This entire quantity is always positive when we substitute this value. Next, for finding the value of this, what we need to do is, the common procedure is, we can't directly find the value, it will be very lengthy. For finding such questions, answer for such questions, we will try to substitute some value of x, so this entire function will be simplified. We can reduce this function. So what we do is, substitute x equal to, we will substitute x equal to cos theta. Why do we need to substitute x equal to cos theta, students? When we substitute x equal to cos theta, this denominator part is 2 cos square theta minus 1, and we know the formula for that. What is 2 cos square theta minus 1? That is cos 2 theta. So this function is actually secant inverse of 1 by 2 cos square theta minus 1. This is nothing but secant inverse of 1 by cos 2 theta. And what is 1 by cos? 1 by cos is secant. So this becomes secant inverse of secant 2 theta. Now what is the answer, students, for this? Secant inverse secant will become cancelled, and when we substitute take 2 theta, what is the answer for this? X theta is cos inverse of x, and this value is always positive here. And what is the range? It is 1 by 2 is 45 degree and 0 is 90 degrees. So this value lies between 90 to 180. So answer secant inverse of secant 2 theta is 2 theta. And what is theta? Cos inverse of x. 2 cos inverse of x. 2 cos inverse of x. Next graph is cosecant inverse x. Next inverse function is cosecant. This is the last function in inverse trigonometry. How to draw a graph of cosecant inverse, students? It is similar to previous cases. First we will draw the graph of cosecant x. Graph of cosecant x is given by sin 0 is 0. Cosecant is reciprocal of sine. So cosecant 0 will be infinity. Sin 90 is 1. So cosecant 90 will be 1. Graph will be like this. graph will look like this. Okay, now this is 0, 90, 180, 270, 360. By observation, this is actually a many to one function, because when you draw a horizontal line, it intersects at more than one point. So we need to make this function as a bijection first. How to make that? We will restrict the domain and choose the principal value branch so that this function is 1 to 1 and it has 0 nearby. So when we consider this region, take this as minus pi by 2, minus pi by 2 to pi by 2, then this region has all the values range of cosecant x, that is minus infinity to minus 1 and 1 to infinity. This region covers all the range, that means this is an onto function, we can consider it like that, and it is following the one to one pattern of the function. So we can take this region as principal value branch. This branch is principal value branch. So what is principal value branch? Minus pi by 2 to pi by 2. And range is between minus infinity to minus 1 and 1 to infinity. So what will be the graph of cosecant inverse x? Cosecant inverse x. Graph of cosecant inverse x is given by, just replace x and y variables. What is the domain of this function? Domain is all real number except at n pi. That means here when we consider minus pi by 2 to pi by 2, range will be minus pi by 2 to pi by 2. This is the domain we have chosen, that means it becomes range minus pi by 2 to pi by 2. N pi does not have 0, so we can replace 0, eliminate 0 from this. So this is minus pi by 2 to pi by 2 and exclude 0. This is the range of inverse function. And now what is the range of this function? Minus infinity to minus 1 and 1 to infinity. So again minus infinity to minus 1 and from 1 to infinity. Now how will the graph of this function look? Sin 0 is, we can take first 90 degrees. Sin 90 is 1. That means sin 90 is 1, cosecant 90 is 1. So that means cosecant inverse of 1 will be 90 degrees. Cosecant inverse of 1 will be 90 degrees. Then what we need to take? Sin 0 is 0, cosecant 0 is infinity. So cosecant inverse of infinity will be 0. Cosecant inverse of infinity is 0. So graph is like this. Then what about the other value? Here minus infinity is also 0. Minus infinity is also 0. And this value is minus pi by 2 is minus 1. So for minus 1, answer is minus pi by 2. So graph of cosecant inverse x is like this. Now what is the domain and range of this function? Domain is all real number except minus 1 to 1 and range is between minus pi by 2 to pi by 2, but it does not have 0 in this. This is how we should plot the graphs of inverse functions. So first we need to restrict the domain and plot the graph of inverse function. It is the same procedure for all the 6 functions. Again it is given by either cosecant inverse or arccosecant. Graph is given like this. This is the summary of all the trigonometric functions, inverse trigonometric functions with domain as well as range. We already discussed what is the domain of sin inverse x, minus 1 to 1, range is minus pi by 2 to pi by 2. Cos inverse x, same domain, range is 0 to pi. Tan inverse x, all real numbers, minus pi by 2 to pi by 2, but the endpoints are not included in that. That is the difference between sin inverse and tan inverse. cot inverse 0 to pi, secant inverse again my 0 to pi by 2, pi by 2 to pi, 0 to pi by 2 exclude pi by 2, that is open interval. Next cosecant inverse x, again same as secant inverse, and range is minus pi by 2 to pi by 2 except 0. Next topic is trigonometric conversions. This is actually an interesting topic. We will use this concept in both trigonometry as well as inverse trigonometry. This is not a separate topic, but it helps in solving problems. How to identify, how to convert between different trigonometric ratios. I will tell one example. We will solve with one example and discuss. That is applicable for all the cases. Let's consider a triangle. Let this be some angle. With respect to this angle, what is sin theta? Let's assume sin x is theta. So let this be x and 1. Let be sin theta equal to x. Sin theta equal to x by 1. What is sin theta? Perpendicular by hypotenuse. This is x by 1, sin theta is x. With respect to this, which means we can write theta is sine inverse of x. We already know angle is the output for inverse trigonometric function. Now what we need to do is express this sine inverse x with respect to cos, tan, cot and other angles. Now how to do that, students? Sin theta is x means what is cos theta? Cos theta is base by hypotenuse. What is base of this? This is a right angle triangle. So base will be root over 1 square minus x square, that is root of 1 minus x square. Now what is cos theta from this? Cos theta is given by root 1 minus x square by 1, which means theta is cos inverse of root of 1 minus x square. Now what we understand, angle is the same, but sin inverse of x is equal to cos inverse of 1 minus x square square root. So this is how we will convert between different trigonometric functions. Now similarly we can do for tan, cot and other angles. We can directly write what is tan theta. Tan theta is perpendicular by adjacent. So this will be tan inverse of x by root of 1 minus x square. What is cot theta? This is again equal to cot inverse of, cot and tan are reciprocals. So it will be 1 minus x square by x. What is secant theta? This is secant inverse of just reciprocal of cos theta. So it will be 1 by root over 1 minus x square. And this is again equal to cosecant inverse of, cosecant and sine are reciprocal. So this will be cosecant theta is 1 by x. So cosecant inverse of 1 by x. This is how we will convert between different trigonometric functions. This is very useful while solving problems. Okay, next is properties of inverse trigonometric functions. This is again a very important topic. You need to be very clear in this. We will discuss all the properties one by one. Sometimes they may ask proof for some property. They can ask questions like that, or we need to verify some property. Questions can be asked like that, or they will give numbers and we will have to apply the property and solve the solution. Okay, now properties of inverse trigonometric functions. First property is, if theta lies between minus pi by 2 to pi by 2, then sin inverse sin theta equal to theta. We already know this, sin inverse of sin theta means it will be answer is theta, and this is only applicable when theta is lying between minus pi by 2 to pi by 2. Why is that, students? Because remember what we did for inverse trigonometric function, we need to make the function as a bisection. That means we are restricting the domain of trigonometric function, then choose the principal value branch. So that means theta lies between minus pi by 2 to pi by 2. We consider that principal value branch and then draw the function for inverse. That means this value of theta should also lie between minus pi by 2 to pi by 2. Only then this answer is applicable. Do you understand this, students? Should I repeat? Theta is between minus pi by 2 to pi by 2 means sin inverse of answer should always be angle, and that angle output should always lie in the minus pi by 2 to pi by 2. That means this answer should always be in this interval. Only then we can write. But remember, sin theta is a many to one function. There can be many values of sin theta having same value. That means if we directly write sin inverse of sin theta equal to theta, then that is not true. For example, what is sin inverse of 1 by 2? We can write sin inverse of 1 by 2 as sin inverse of sin 30 degrees. If we write it like this, answer is 30. Also we can write this as sin inverse of sin of 180 minus 30, because sin of 180 minus theta is also sin theta. That means this is sin of 180 minus 30. That is equal to sin inverse of sin of 5 pi by 6. Now if we compare these two, can we write this answer as 5 pi by 6? No, because sin inverse of sin theta is theta by this definition. So both these answers are correct. That means it is obviously wrong, because only when theta lies between this interval we are defining sin inverse curve. So theta, whatever value we find for theta, should always belong to minus pi by 2 to pi by 2. Whether this value 150 degree is in between minus 90 to 90, obviously not. So this is wrong. Don't do this. So we need to make sure for questions like this, we need to convert sin 5 pi by 6 is also equal to sin pi by 6. So answer should be written as pi by 6 only. Okay, next property is cos inverse cos theta equal to theta. Again remember, it is the same way for all the properties. Cos inverse cos theta is theta, and what should be theta? Cos inverse lies between 0 to pi. So if theta is in between 0 to pi, cos inverse cos theta is theta. Same, tan inverse tan theta equal to theta. Theta lies between minus pi by 2 to pi by 2. Cot inverse cot theta equal to theta. Theta lies between 0 to pi. You should be very clear in your mind what is the principal value, range and domain of all the inverse trigonometric functions. Then only we can apply this. It is not useful for memorizing these properties. It will be tough. So remember the concept, graph and understand the topic. Then the next topic is secant inverse secant theta is again theta. Theta lies between 0 to pi except pi by 2. Same for cosecant. Cosecant inverse cosecant theta equal to theta. Theta lies between minus pi by 2 to pi by 2 excluding 0. This is the first property. Second property is sin of sin inverse x. What is the difference between both these, students? First one is sin inverse of sin theta. That means sin inverse of sin theta is always angle theta. Here sin of sin inverse x. Again answer will be whatever in place of theta, that will be that. Here theta is in radians. Sin inverse of sin inverse x is x. And remember, this is only possible when sin inverse of x is only possible when x lies between minus 1 to 1, because only when the domain is there we can take the value of sin inverse. So this x should belong to minus 1 to 1. Only then we can write this property. This curve sin of sin inverse x exists only in this region, not like previous time. In the previous time we have discussed an example. This curve we can find many values of theta that satisfy this. So we need to be converting this. For the second property, it is not like that. This curve only exists in this region because sine inverse of 2 is not defined. Sine of sine inverse 2. Not this answer is not 2. So remember this. No. Similarly, cos of cos inverse x. Again, the domain of this cos inverse will be the given condition. Tan of tan inverse x. Tan inverse domain is all real numbers, so x belongs to R. This function exists for all real numbers. And cot of cot inverse x equal to x. Now what will be the graph of this function? I will explain in short so you will understand it better. First we need to draw sine of sine inverse x. What is given? This is taken as y. So y equal to x line will be there. And what is the x values? Minus 1 to 1. So between minus 1 to 1, y is also minus 1 to 1. Graph is like this. At other regions, this graph does not exist. Same for cos inverse also. Cos of cos inverse x equal to x. X lies between minus 1 to 1. For both the graph is same. What about next one, students? Tan of tan inverse x is x. Now the graph is x belongs to all real numbers. That means y equal to x is the curve and it belongs to all real numbers. That means this is a straight line y equal to x. Complete line. Same for cot of cot inverse x. Both these graphs are same. Next one. Secant of secant inverse x is also x, but the graph domain is between minus infinity to minus 1 and 1 to infinity. So what will be the graph, students? This is first two questions. This is third and fourth property graph. This is fifth and sixth property graph. The graph of this function will be again 1 minus 1, 1 minus 1. Between this region, the graph exists, not in between minus 1 to 1. All the graph has the same value, y equal to x, but the region in which the graph is defined varies. Next one, third property, sine inverse of minus x equal to minus sine inverse of x. Remember, when we draw the graph, one observation we made is sine inverse graph is symmetrical about origin. What does that mean? Whenever a graph is symmetrical about origin, it is an odd function. What is the property of odd function, students? Odd function is defined as f of minus x equal to minus f of x. That means sine inverse of minus x equal to minus sine inverse of x. Next one, cos inverse of minus x equal to pi minus cos inverse x. Now how to identify this? Prove this. I will explain in short. Cos inverse of minus x equal to pi minus cos inverse x. What we need to do first is, let's take left hand side as some angle theta, because we know inverse function always has the output as angle. So this is cos inverse of minus x equal to theta. Let this be theta, some angle. Now what is minus x from this? Minus x is cos theta. And what is x? X equal to minus of cos theta. Now how to write this? Minus cos theta. We already know cos 180 minus theta is minus cos theta. So we can write this as cos of 180 pi minus theta. These two are same. That means pi minus theta is pi minus theta equal to cos inverse of x, cos inverse of x. Which means what is theta? Which implies theta is equal to pi minus cos inverse of x. Pi minus cos inverse of x. This is right hand side, pi minus cos inverse of x. That is the proof for this. Similarly, we can prove for all the properties. Third one, tan inverse of minus x is minus tan inverse x. Just like sin inverse, it is also an odd function. So tan inverse minus x is minus tan inverse x. Cot inverse of minus x is pi minus cot inverse x. Similar to cos. Secant inverse, again pi minus secant inverse x, and cosecant inverse minus x is minus cosecant inverse x. Sin, tan and cosecant, these three are odd functions. Cos, cot and secant will have the value pi minus cos inverse x. Next, sin inverse of x equal to cosecant inverse 1 by x. This value exists when this x should lie in the domain of sin inverse. That means this is possible only in between minus 1 to 1. And remember, when we write in terms of cosecant, 1 by 0, cosecant theta is reciprocal of sin theta. That means it will become 1 by 0. So 0 cannot occur in between minus 1 to 1. So exclude 0 and take the remaining values for domain. That is minus 1 to 1 excluding 0. Sin inverse of x equal to cosecant inverse of 1 by x. Just like how we did in the previous question, we can do for this also. Take sin inverse x is theta, x is sin theta. Take x, sin inverse x equal to theta, which means x is equal to sin theta. From this, what is cosecant theta? 1 by x is cosecant theta. And what is theta? Cosecant inverse of 1 by x. Cosecant inverse of 1 by x. That is the proof for this. In the same procedure, same way, we can prove for all this. Because sin and cosecant are reciprocal, cos and secant are reciprocal, tan, cot is reciprocal. So similarly, we can do for all the values. Tan inverse 1 by x is cot inverse 1 by, tan inverse x is cot inverse 1 by x. Again, sin inverse of cos theta. Here we can add other three properties. Suppose we want to find cot inverse of x. Cot inverse of x is tan inverse of 1 by x, provided that value lies in the interval. Similarly, secant inverse x equal to. That means this x should lie in the domain of secant inverse. That is between minus infinity to minus 1 and 1 to infinity. We should be careful with that. Don't take the same and memorize this. Cos inverse x means x should be in the domain of cos inverse. That is minus 1 to 1. Similarly, you should solve for other. Next property is theta lies between 0 to pi. Then sin inverse of cos theta equal to pi minus 90 pi by 2 minus theta. This is very easy. We already know sin inverse sin theta is theta. Now what we need to do is write this cos theta in terms of sin theta. What is cos theta? Sin 90 minus theta. So this is sin inverse of sin 90 minus theta. That is 90 minus theta. Proof is as simple as that. Same way, other trigonometric ratios. Cos inverse sin theta is pi by 2 minus theta. Tan inverse cot theta. Cot inverse tan theta is pi by 2 minus theta. Same for other. Next property is, this is very important property. We will use that not just in this chapter, in other chapters also it can be used. And this is a very basic property, you should remember it well. Sin inverse x plus cos inverse x equal to pi by 2. Sometimes questions can also be asked. Based on this property, we will prove the values or find the value of some functions. So cot inverse x plus tan inverse x equal to pi by 2. Secant inverse plus cosecant inverse x equal to pi by 2. Proof is very simple. Take any value Let's take cos inverse x equal to theta. Let's take cos inverse x equal to theta, which means x is equal to cos theta. This is equal to sine of 90 minus theta, which means sine inverse x is equal to 90 minus theta. Now what is cos inverse x plus sine inverse x? Cos inverse x is theta plus sine inverse x is 90 minus theta, 90 degree minus theta. This is nothing but 90 degrees. Same way we can do for other two also. So sine inverse x plus cos inverse x is 90 degrees pi by 2, tan inverse plus cot inverse pi by 2, secant inverse x plus secant inverse x is pi by 2. Next property. Again, this is the property for circular trigonometric functions. When we add two angles, how it will be? Sin inverse x plus sin inverse y is equal to sin inverse of x into root 1 minus y square plus y into root of 1 minus x square. Proof is very simple. Let's assume sin inverse x is some theta, some alpha, beta, a, b, any value. Let's take sin inverse of x equal to a, sin inverse y equal to b, sin inverse of y equal to b. Now what we need to do is sin inverse x plus sin inverse y, that is nothing but a plus b. We will take sin of a plus b. What is the formula for sin of a plus b, students? Sin a plus b is equal to sin a cos b plus cos a sin b. Sin of a cos b plus cos a sin b. Now what is sin a? Sin a is x. We will write sin a is x, which means from this what is cos a? Cos a is root 1 minus x square. Similarly sin b is y. Sin b is y. Cos b is root 1 minus y square, which means sin of a plus b is equal to sin a, that is x, cos b, that is root 1 minus y square, plus cos a, that is root 1 minus x square, into sin b, that is y. This is sin of a plus b. That means a plus b is equal to sin inverse of this answer. And what is a plus b? Sin inverse x plus sin inverse y. That is the proof for first condition. Similarly, we can prove all the other property. Sin inverse x minus sin inverse y. This is nothing but a minus b. What is sin of a minus b? Sin a cos b. That is x into root of 1 minus y square minus cos a sin b minus y into root of 1 minus x square. Next property, cos inverse x plus cos inverse y. Again take this value as a and b, a plus b. Cos a plus b is equal to cos a cos b, that is x into y minus sin a sin b minus root 1 minus x square root 1 minus y square. Proof is similar to how we did here. Everything is same. Next, cos inverse x minus cos inverse y. Cos a minus b, cos a cos b plus sin a sin b. A x into y plus root 1 minus x square into root 1 minus y square. Okay, next one. X greater than 0 and y greater than 0. Xy is less than 1. Then tan inverse x plus tan inverse y is equal to tan inverse of x plus y by 1 minus xy. We will discuss the proof little bit after this. Same way, tan inverse x plus tan inverse y is equal to pi plus tan inverse of. What is the difference between these two, students? Here x and y should be greater than 0 in both the cases and xy is less than 1, xy is greater than 1 in the second property. Remember this is very important. Next, x less than 0 and y less than 0 means tan inverse x minus tan inverse y is equal to tan inverse of x minus y by 1 plus xy. I will explain how to prove or how to write these formulas in a bit. These are the three formulas. Next formula is 2 sin inverse x equal to sin inverse of 2x root 1 minus x square. Again, proof is very easy. Take sin inverse x is theta. Sin inverse x is theta. That means x is equal to sin theta. And left hand side is actually 2 times theta. And what is this value? This is when you take sin 2 theta is equal to this value. That is what we need to prove. What is sin 2 theta? Sin 2 theta is equal to 2 times sin theta cos theta. We already know the trigonometric formulas. So sin 2 theta is 2 sin theta cos theta. This is equal to 2 sin theta is x. What is cos theta? Root of 1 minus x square. So 2 theta is actually sin inverse of 2x into root of 1 minus x square. That is what we got. This is possible in this given interval. Why is that important? Because between minus root 1 by root 2 to 1 by root 2, what is x? Sin theta. What is sin theta here? X is this one. Sin theta is given like this. Sin theta is between 1 by root 2 to minus 1 by root 2. So what is theta from this? Theta will be in between. This is minus 45 up to 45. What is 2 theta? 2 theta will be in between 90 and minus 90. And remember, sin inverse curve exists in this region alone. For other regions, if you want to find that, then we need to convert this into this region angle. Only then we can solve. So in this region, minus 1 by root 2 to 1 by root 2, this formula is applicable. Okay, next one. 2 cos inverse x equal to cos inverse of 2x square minus 1. It is again same as previous. Let's assume cos inverse x equal to theta and simplify. Proof is similar to that. What is x? Let's assume x equal to cos theta. Cos inverse x is theta means x equal to cos theta. So this is nothing but 2 cos square theta minus 1. That is cos 2 theta. Cos inverse cos 2 theta is 2 theta. Okay, this is not given in your NCERT, so remember this formula first. 2 tan inverse x is again tan 2 theta, 2 tan theta by 1 minus tan square theta. Substitute x equal to tan theta. Then left hand side is 2 theta, right hand side is 2 tan theta by 1 minus tan square theta is again tan 2 theta, tan inverse tan 2 theta is 2 theta. And remember how to write this. Whenever we have 2 theta, that means try to make the domain decrease, divide it by whatever number is in the coefficient. Then we can write the answer directly. There is no change in the formula. Remember it like this. It is very easy. That means 2 theta should lie between minus 90 to 90. That means theta is minus 45 to 45. That means what is sin theta? Write it here. Similarly, 2 cos inverse x is between 0 to pi. Similarly, we can write this and find the value of x. Similarly, for tan. Tan 2 theta is, that is, tan inverse x is between minus pi by 2 to pi by 2. That means 2 theta should lie between that. So, theta should lie between minus 45 to 45. Similarly, you can prove the other. Next, we will discuss the proof for this. Tan inverse x plus tan inverse y is equal to tan inverse of x plus y by 1 minus xy as well as pi plus tan inverse of this. Only difference is xy is less than 1 in the first case, xy is greater than 1 in the second case. First, we will take the first condition. How to prove this? We already assume x and y is greater than 0 and xy is less than 1. X is greater than 0 means what will be tan inverse x? We already know tan inverse x graph, that is all real numbers and value is between minus pi by 2 to pi by 2. For all real numbers, it is always increasing. Tan inverse 0 is 0. After 0, it is a positive value. So it lies between 0 to pi by 2. Similarly, y is also same. Y greater than 0 means tan inverse y also lies between 0 to 90 degrees. Now, when we add these two, what is the answer? Let's assume this is alpha and beta. Then alpha plus beta will lie between 0 to 180 degrees. So that means x is equal to tan alpha, y equal to tan beta, and we already discussed this. So when we add these two, it lies between 0 to 180 degrees. Now what is tan of alpha plus beta? Tan of alpha plus beta is tan alpha plus tan beta by 1 minus tan alpha tan beta. That is nothing but what is tan alpha? X. Tan beta? Y. So this is x plus y by 1 minus xy. Now what we need to remember is, I think up to this step it is clear for everyone. Here comes the very important part. Up to this is standard for all the questions. Previously what we did, whatever is the statement that we need to prove, take the left hand side and take the answer as some angle. That is tan inverse x is some angle theta, gamma, alpha, beta, any angle that you choose. Similarly, tan inverse y is beta, or you can take a and b. Then find the value of this. What is tan of alpha plus beta? We already know the formula and substitute in this. Up to this is standard for all the proof, all the questions. After this, what we need to do is, what is the value of this? Is it positive or negative? Remember, we choose the condition that x is greater than 0, y is greater than 0 and xy is less than 1. That means x is greater than 0, y is greater than 0. So x plus y should be positive and xy is less than 1. That means 1 minus some number less than 1, that is also positive. Numerator and denominator is positive means this quantity is always positive. Now remember, tan alpha plus beta is a positive number. What does that mean? Tan of alpha plus beta. Tan beta is positive means theta lies between 0 to 90. That means alpha should lie between 0 to 90 degrees. So alpha plus beta, here theta is nothing but alpha plus beta. So alpha plus beta lies between 0 to 90 degrees. So from this, 0 to 90 degrees is already in the domain. So we can take it as it is. That is the proof for first one. So tan inverse x plus tan inverse y is equal to tan inverse of x plus y by 1 minus xy. Second case, x is greater than 0, y greater than 0 and xy is greater than 1. Now again proof is similar to this. X and y is greater than 0 means tan inverse x lies between 0 to 90, tan inverse y lies between 0 to 90. So let this be alpha and beta. When we add these two, it lies between 0 to 180. When we add these two, it lies between 0 to 180. I think it is not printed. Okay, we will do this. Alpha plus beta is between 0 to 180 degrees. Alpha plus beta lies between 0 to 180 degrees. And what is alpha? Tan inverse x. Beta is tan inverse y. I think that is what is given here. Yes, alpha is tan inverse x, beta is tan inverse y. X is greater than 0, y is greater than 0 and xy is greater than 1. Okay, now what is tan of alpha plus beta? Tan of alpha plus beta is equal to, again formula is same, tan alpha plus tan beta by 1 minus tan alpha tan beta. Now what is this value? This is x plus y by 1 minus xy. Now if this value is positive or negative, here x is greater than